Good day, sir. This is our preliminary requirements for this subject, and we are here today to explain the following. First is convert to bits. Second is initial permutation. Next is expand right. Fourth is XOR subkey. Fifth is substitute. Sixth is permute. Next is XOR left. And number 8 is rotate halves. And lastly, extract bits. So let's begin with the convert to bits. In the table below, with the given 16-bit key, we will be converting the 16-bit key to binary, using the hex method in getting the text in the binary. We will be entering the resulted binary in the converting bits row. As you can see, this is the converted bit key to binary. So this is the converted bit key to binary in this row. So after converting to bits, the next step will be doing the initial permutation. The binaries from the converting to bits row, which has become a 16-bit binary, it will be a 15-bit binary because of the initial permutation by rearranging it in a specific way, or by taking of 1 bit each the binaries, so that we can have result of only 15-bit. So this is the 15-bit binary. In this initial permutation row. So next is expand right. After doing the initial permutation, we only have 15-bit binary. Next is that we will be chopping it into half, the left and right. The left side will have first 6-bit binary. So this is the 6-bit binary. And of course, the right will have the 7-bit binary. So this is the 7-bit binary in the expand right row.
So I'm going to discuss to you the XOR subkey, the substitute, and permute. So first is the XOR subkey. So to get this is we must use the expand right and this column. So first, 0 plus 0 is equals to 0. Then 1 equals to 1 plus 0 is equals to 1. Then 0 plus 1 is equals to 0. If the number is same, then the result will be 0. Then if the number is 1 plus 0 and 0 plus 1 is equals to 1. So let's move on to substitute. So how did I get the 001110? So first is I use is the XOR sub key. Then as you can see, the right and left side, the 0 is colored orange and the 111 is green. Then so the real number of 1111 is 15. So next, we'll be using the 15 in this chart. So we'll be starting in 14. The start is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then we get 7. So the binary of 7 is 0, 1, 1, 1, 1. So that's how you get the substitute. So let's move to permute. So to get the permute, we have a chart that we need to follow. So first is we have the 16, next is 7, then next is 20, 21, then 29, 12, 28, 17. To get the permute, we must follow the box. So first we have 16, then we must find 16 in column in substitute. So we have 0, then we will put it there. So we have 0. So next we have the 7. We must find 7 in substitute. Then the 7 is 1. Then we will put it 1 also in there. So let's continue.
So here the XOR left, the 32 bits yellow highlighted, you will be copy the yellow highlighted in the initial permutation and paste in the XOR left. So in the remaining 32 bits will be the combination of initial permutation as permute. So 0 is to 0 will be 0, then 1 is to 1 will be 0, and then 0 is to 1 will be 1. If they are the same, the result will be 0, and if they are different, will be 1. Then next will be the convert to bits. So the convert to bits will be the result of k input here, and then the initial permutation will be the PC1 permutation table 1. So 57 first will be 57 is 0, and 49 is 1, and so on. The initial permutation having 48 bits, and then next will be the rotate have left 1. So in rotate have left 1, you need to divide the initial permutation into 2, so that you have a C0 here and D0, and then in the bits having each having 28 per bits, 28 per in the C0 and D0, and then you need to rotate have left 1. So in that case, you need to start in the second in the initial permutation, and so on, and then the last one will be the 28 bits, and also in the D0, that's the same here. You get the port 56 bits in the rotate have 1, and the extract bits here. The extract bit you need to follow the permutation table 2 here. 14 is in 14. Where's the 14 here? 14 is 0, so that 0 here. And then 17, 17 is 0 again, so 0. And then 11, where's the 11 here? See, 11 is 1, and so on. And so the extract bits will be the third, what is this, 48 bits, not the same in the rotate have 1, because in the you need the in the extract bit having a selection bits in the rotate have 1, so that the extract bit having a 48 bits. And that's all. Thank you.